This kind of nano structure, because we can create some new functionality, and we can actually have many different kind of application. And one particular research we're doing is using a so-called matter surface. So we're patterning the structure in a really small dimension, so that you can control the light in a really unique way. For example, we can control the light when they're coming in, they can go to any direction you want, or you can even focusing the light in a really thin layer. We're talking about maybe 100 nanometer of layer. So this could be really useful for many device application. For example, your camera, you need different kind of lenses, filter, etc. At the same time, we can also making, for example, absorbing the light for 100% in really small dimension, or even making a color filter, etc. So all of this could be using for imaging, sensing, and even some communication application. Another area we're also working on is optical fiber. And optical fiber have been used for a really long time for internet. For example, we're using light for transmitting really fast communication, internet network using optical fiber. But typical optical fiber, you have a fixed limitation because of the glass material. But now we're actually making some new kind of fiber. We can have a tiny channel inside the optical fiber, so that we can integrate some material, new material, to have this kind of new light-matter interaction for some new phenomenon, so that we'll be able to use for telecommunication. At the same time, we're also making some nano structure to even controlling the property of the optical fiber, where people haven't been able to do it before. So this could be a lot of potential for also the optical sensing, and also for maybe future communication, high-speed communication application as well. So for example, we're making this kind of a matter surface with really thin surface, and we can have different functionality. As I mentioned, you can making a perfect absorber, 100% absorber in only maybe 10 nanometer of 15 film. At the same time, you can making color filter, or even beam splitting device. You can spin the light. So, but what we try to do is even trying to actively control it by applying bias. You can control, let's say, which color you want to absorb, or which wavelength, or which color you want to transmit. So you can have a full functionality just by applying bias. That means you can use it for electronic device, or optic electronic device. For example, for our smartphone, we have different displays, and also different kind of CMOS camera there. We can use this kind of ultra-thin optics for active functionality. If we can integrating really thin optical component, let's say holograph, filter, or even a kind of imaging sensor, etc., in a really thin dimension, that could be a breakthrough for also some of the imaging system, let's say this kind of a Google Glass, etc.